This is what we want to build, drill-powered go-kart for kids. Previously, we finished here. We designed the basic board, the front axle and the steering system. And this is what we will design in this video. We are going to add the seat, mount the rear wheels and start to work on the gearbox. Welcome to the video of the series How to design and build a drill-powered go-kart with your kids. Let's get started. So, we continue in Fusion 360 right where we left off. You will need to adjust it depending on what kind of seat you have available and how you decide to use it. I used this old black chair that someone threw away. First I removed the backrest. Then I cut the steel frame behind the backrest so that when I put it back on, the backrest would touch the lower part, as you can see in the picture. Next, I cut off the legs of the chair. I kept one of them, which I'll show you how I used in just a moment. After that, I turned the whole chair upside down and mounted it onto the go-kart the opposite way from how it was originally used. In other words, the seat and the backrest ended up reversed. I did this because on what was originally the bottom part, but now serves as the backrest, there are steel tubes. These tubes will be useful for attaching other parts of the go-kart, such as the seat mount, the throttle lever for pressing the drill trigger, or the spring attachment for the lever. I'll show you all of that in the next video. So, that's all for the chair design. Now I will take the seat and drill 4 holes for mounting it onto the baseboard. The holes I made were 6 mm wide, and it's important to drill through the steel frame. Then I placed the chair on the baseboard, mark the holes from the seat onto the board, and drill them as well. After drilling, I attach the seat with M6 carriage bolts. I think they are the best choice for this application, and secure them with washers and M6 lug nuts. Now it's time to show you how I recycled one of the chair legs. I used it as a support for a steering wheel tube. I sketched it out, as you can see in the time-lapse. On this leg, a linear coupling SHF20 will be mounted. Inside the coupling, the steering tube will be inserted. During actual driving, the coupling won't be tightened. It will stay loose, so the tube can rotate freely inside. You might ask why I don't use a bearing for this purpose. The answer is simple: I already had a coupling left over from a previous project. But if it works better for you, you can definitely use a bearing instead of coupling. I attach it using bolts and lock nuts again. To mount it, I first had to drill holes into the chair leg. But before that, the leg needed to be cut so it could fit under the steering tube. So first, I slid the linear coupling onto the steering tube. Just for this step, I tightened it roughly in place, so that the chair leg lined up with the front edge of the seat. Then, I measured the distance from the bottom of the coupling to the baseboard. I marked this measurement onto the leg and cut off the same leg from both ends. Once the leg was cut to size, I placed it under the coupling, lined up with the front edge of the seat. Next came drilling the holes, which was a bit tricky, since I had to drill at an angle on an uneven surface. To make it easier, I cut an opening on the opposite side of the leg, so I didn't have to drill through the tube twice, only once. I'm sure you get the idea. For attaching it to the baseboard, I used corner brackets, but first they had to be bent to match the angle of the leg. To fasten the brackets to the chair leg, I used M5 bolts with lock nuts, and the same type of bolts for attaching them to the baseboard, just in a different length. Before we move on to designing the gearbox, I want to let you know that all the material used are listed in a sheet available on a Google Drive. Also, the parts from the previous and the next videos. The link is provided in the description. If you find this video valuable, please hit like and subscribe to the channel. It would mean a lot to me. Thank you. Now, let's jump into designing the gearbox. I'll start by explaining how I approached the design. If you look at other drill-powered go-karts videos, most of them, if they had a gearbox, they used gears from a kid's bicycle. But since my son's bike was untouchable at the time, and at work we were using pulleys and belts, I decided to go with this alternative. We will begin the gearbox design with the bearing. I downloaded its 3D model from GrabCAD. The link is in the video description. For the gearbox, we will use two UCP 204 bearings, into which we will insert a 20 mm shaft. Between these two bearings we will place a pulley with 44 teeth, type HTD 15. This pulley is one of the parts that needs to be modified directly by the supplier or by you. First, the inner diameter must be enlarged to 20 mm, and then two holes needed to be drilled and threaded so the pulley can be secured to the shaft with grab screws. If you order this part, you can simply add a note with the modification you need, or even attach the technical drawing that shows exactly how it should be adjusted. The drawing is available for free in the Google Drive mentioned earlier. Link is in the description. Name of the drawing in the folder is pulley44t.pdf. There is also DWG version if necessary. Once the part is modified, we mount it onto the shaft and secure it with the M5 grab screws. Next, the go-kart wheel needs to be attached to the shaft. The wheel has the same size as the front ones, 260 mm. I mount it as follows. First, I drilled two holes into the wheel at a spacing that allow me to connect it with an SK20 coupling. So right behind the gearbox I place a coupling, then the wheel. For the two drilled holes in the wheel I inserted cut pieces of M6 threaded rod. On the other side I added another coupling SK20. The threaded rods were secured with lock nuts tightened on both sides. Of course, you could use long M6 bolts, but since I already had threaded rod, I went with that. When is rear axle finished, we attach it to the baseboard. I used M12 screws, but them I will show in the next video. And with that, the left rear wheel is mounted. Now we can move on to the final part of this video, attaching the right rear wheel. The design of the right rear wheel is very similar to the front wheels, with just a different method of wheel holder. To make it easier, I copied the front wheel design and removed the parts that weren't needed. What remained was the 26 mm wide wheel, an M12 lock nut, two wide washers and standard M12 nuts to create spacing and prevent the wheel from rubbing against the baseboard. As shown in the 3D model, at the end I needed 3 nuts for spacing. 2 wouldn't have been enough. Of course, inside the wheel there is also a mounting sleeve, just like in the front wheels. Next, I measured the position of the wheel from the basic board by measuring bearings distance and drilled a 12 mm hole in the baseboard at the correct spot. On the other side, I secured the wheel mount with a lock nut. From the top, two 6 mm holes are drilled through the wheel holder, and the whole assembly is mounted to the baseboard using M6 screws, washers and lock nuts. So that's it. We designed the seat, the rear axle and started working on the gearbox. In the next video we will finish the gearbox, insert the drill and secure it to the go-kart. If you haven't already, I'll really appreciate it if you subscribe to the channel so you don't miss the next video. If you enjoyed this one, don't forget to give a like. But most importantly, spend time with your kids building stuff.